Hello everyone, my name is Alisa Bilanovic. I'm from Karasin, Kharkiv National University.
Ukraine. My co-authors are Alexander Kuznetsov,
Kuznetsov, Manuel Fontenuk, Sergei Kandi, Tatiana Smirnova, and Sergei Prokopov. Today I would like to present you the new cost function for S-box generation by simulated annealing algorithm. The purpose of the study is to present a new cost function to solve the problem of generating nonlinear substitutions, which mean S-boxes, in the space of all 8-bit permutations. We have identified the following tasks in creating the new function. Firstly, we want to continue the study of simulated annealing algorithm. Secondly, we need to create a new improved S-box generation function and optimize its parameters. Thirdly, we want to reduce the generation time of 8-bit S-boxes with nonlinearity 104. And fourthly, we want to reduce the number of iterations required to find S-boxes. Simulated annealing algorithm refers to the heuristic class of global optimum search. For the computational algorithm for global optimum, the metal cooling process is simulated as simple formats. Possible alternative in the search space is evaluated and ranked using the cost function. We set the initial temperature and calculate the probability of transition between the cells of crystal lattice. In the search algorithm, this probability will define the adoption of the worst alternative. We are gradually reducing the temperature, and the likelihood of adopting deteriorating alternatives is also diminishing. As a result, only improving alternatives will be accepted at low temperature and the process is frozen. Therefore, to implement heuristic search, it is necessary to set several parameters of imitation annealing, which are initial temperature, cooling coefficient, and the cost function for comparison and ranking all alternatives. The simulated annealing algorithm is motivated by physical considerations. The most advantageous energy state of the thermodynamic system is determined by the Boltzmann distribution. The probability ratio of two states is called the Boltzmann factor, which usually depends only on the difference between the energies of states. Simulated annealing algorithm simulates physical processes of thermodynamic system. The cost function ranks these states. The probability ratio, which is the Boltzmann factor analog, calculates the probability of a system moving from one state to another. To imitate the simulated annealing algorithm, it is necessary to select the cost function whose values rank the states, as well as to optimize the algorithm by the temperature value. We consider the generation of 8-bit S-boxes, which are given as a vector function. The most advantageous energy state of the thermodynamic system is determined by the Boltzmann distribution, which is represented as P in the formula below. In this formula, E, the energy of the ith state, K is Boltzmann constant, and Z is normalization constant defined in such a way that the sum of probabilities of all I is 1. The probability ratio of two states is called the Boltzmann factor. It usually depends only on the difference of energies of states. The Boltzmann distribution shows that states with lower energy will always be more likely. Therefore, the Boltzmann distribution is usually used to solve a variety of tasks. Consider the cost function FCF, whose values rank the states as I. In this way, a function is the energy analog of the I state of E in formula of Boltzmann distribution. The probability of finding the system in the I state by analogy with formula of Boltzmann distribution right in the form below. The probability ratio should be written as follows formula. It calculates the probability of a system moving from one state to another. It is already known that in order to imitate the simulated annealing algorithm, it is necessary to set the cost function FCF, whose values are the states Si, as well as to optimize the algorithm by the temperature value T. The most optimal parameters for the previously optimized function were as follows. Initial temperature T0 was 20,000 and cooling coefficient alpha was 0.95. For comparison and ranking of alternatives was used the cost function where x and r were configurable parameters and WHT were Walsh-Adamar transform coefficients. To solve the problem of finding nonlinear 8-bit S boxes, we offer to use the cost function 8, where x and r are configurable parameters. We have conducted numerous experiments with the cost function 8. To find substitutions with nonlinearity 104, we use the algorithm of simulated annealing with parameters of T0 20,000 and alpha 0.95. The aim of our experiments was to optimize the parameters x and r in 8I to find the combination of parameters that require the least number of iterations of the search algorithm. The results of experiments are visualized and shown as a diagram, which represent average number of iterations of the simulated annealing algorithm with the new cost function. The obtained results show that the new cost function gives high efficiency of search in a wide range of parameters x and r. On average, the simulated annealing algorithm requires about 80,000 iterations to find 8-bit S boxes with a nonlinearity of 104. For x greater than 40 and y greater than 16, the difficulty is increasing. For example, with x greater than 44 and y greater than 20, we couldn't find any S boxes with nonlinearity 104. Compared to the best known result for the simulated annealing algorithm, we managed to reduce the average number of iterations by 5.6 times. The probability of finding 8-bit S boxes with nonlinearity 104 was 100%. The best obtained result was about 67,750 iterations, which roughly corresponds to the best known result for the hill climbing algorithm. So we showed that the simulated annealing algorithm can provide very good results in generating nonlinear substitutions for cryptographic applications. In conclusion, we can say that nonlinear substitutions play an important role in cryptography. They provide nonlinear data transformation and protect against some cryptanalytic attacks. For example, differential, linear algebraic, and many other types of cryptanalysis. Thus, high nonlinear substitution generation is a topical field of research in the modern computer science. Our research consisted in developing a new cost function for heuristic search of 8-bit S boxes with nonlinearity of 104. We have conducted numerous experiments and have shown that the computational complexity of the simulated annealing algorithm can be significantly reduced. By the number of iterations of the search, our cost function shows better values for the simulated annealing algorithm and some better than other heuristic algorithms. A promising area for the future research is the use of a new value function in other heuristic search algorithms, for example, in local optimization and hill climbing algorithms. Thanks for your attention.